Okay, I guess we'll go ahead and get started. All right. Well, welcome to Inspire Me seminar for this week. Really enjoyed seeing a nice group of students here and faculty. That's good. If you haven't signed up on the sign-up sheet, please make sure and do that either as we send it around or maybe when you're on the way out the door. We like to keep track of who all's coming, get a sense for what students are here from what classes and that sort of thing. So anyway, thanks for coming. Today we have a very special presentation, industry panel from a local group here in Boise, Idaho, I guess, actually out of Haley, right? That's the headquarters. Is that still true?
Yeah, but we're the biggest office.
Oh, you're the biggest, okay. Well, their headquarters is now moved to Boise, it says. So POWER Engineers is here. They do a lot of work worldwide in a variety of different power type technologies. And so these guys are here to help you to help discuss a little bit about what they do and maybe have opportunities for questions and answers. And I would guess that they might entertain very broad questions about the industry and as well as maybe specific questions about their own about their facility or their company as well. So feel free to jump in and have questions. We'd like to be a pretty interactive group. So well, without further ado, I'm going to go ahead and introduce our ringleader here. Tony Clark's here from POWER Engineers, and he is. I'm going ahead basically. He's on our industrial advisory board, so that's one of the ways I know him. The other way I know him is he's also one of the organizers of our local or regional ASME group here in town, professional society. So he's got a lot of connections within broader than just power industry. So he's a good guy to know. He got his degree from Missouri Rolla, University of Missouri Rolla.
That's what they called it back then.
Yeah, that was back in the day, right? I was going to say it's nothing now. It's S&T.
Missouri Science and Technology. Is that right?
I think
Has
so.
anybody checked it out more recently?
I think that's what it's called now too. But
Yeah.
so and he's been working, I believe, since 2008 with POWER Engineers. Before that, he's working in the power industry with Siemens, I believe. And so he has a long history of experience in the area. And so he's going to be moderating the discussion. I'm going to turn it over to him and let him introduce his other panel members.
Okay.
So thanks, Tony.
Thanks. Thanks, Don. A little bit about POWER Engineers. I'm sure you guys have heard a little bit about us. We've acquired a new company recently, a few of them. So we're based in, headquarters is still officially in Haley, but biggest office is in Boise. We have 40 offices around the country and a few international ones too. Johannesburg, one in the UK, one in Finland, and I'm missing one. No, I think that's all of it right now. We have 2,400 employees with the recent acquisition of Siga Engineers in Kansas City. That was another 100 or so. That just completed this summer, so those are good guys to have on the team. And we have annual revenue last year was about $350 million. A big chunk of that is power delivery. The whole transmission distribution industry is going bonkers right now. 80 million of that was from generation, which is where Steve, Josh, and I work. It's about a quarter of the headcount for the company, and so we do pretty well. It's a tough industry, and we'll get into more about that later. Yeah, my career started off in 2001. Back in May, it was a little disrupted in September. Some of you guys might remember that, but it was a tough time. I was lucky to get a job when I did because the ensuing recession was really rough on the people that graduated in December. But I worked as a field engineer for Siemens for 7 years, and then came to Boise in 2008. Moved here with my wife. She was pregnant, so it was time to not be a field engineer anymore. Traveling like 80% of the time. So great experience. Recommend it to all the young people out there, but you outgrow it. So it's tough. So I'd like to introduce my colleagues. Steve Harris. He's a senior project manager for us. He started about 6 years ago. Yeah, at Power. He had a long career before that. And then Josh Gunderson, he's a Boise State graduate, and he's been at Power about as long as I have.
Yeah.
But that was straight out of college, and
Yeah.
he had a little side endeavor in the middle there too.
Yeah.
So, go ahead, Steve.
Yeah, my name is Steve Harris, and I was joking with these guys when we came over. We had to bring old, medium, and young, and not the young one. I graduated from Gonzaga in 1980, before they became good at basketball. So people laugh. When I went to Gonzaga, John Stockton was still in high school, so we get joked about that. So we used to go to this one restaurant that his parents owned, and we used to leave him quarters to pick up our beer glasses. He's NBA Hall of Fame. But anyway, as opposed to when Tony graduated, when I graduated in 1980, the energy industry was booming. If you didn't have 6 jobs offers by the time you graduated, you weren't even looking. And so at the time in Washington, Boeing was hiring every engineer that could graduate from the universities. The oil companies were all ramping up. The power industry was booming. They were building nuclear power plants everywhere in the United States. I went to work in 1980. I went to work for Bechtel, which was one of the largest architect engineering companies in the United States. They do work internationally. At the time I went to work in 1980 in San Francisco, they had 300 mechanical engineers designing power plants, just mechanical engineers. At the time we were designing 3 nuclear power plants, 2 large coal-fired power plants, and a number of other projects. So those were huge multi-year engineering projects that took a team of people. You worked on a project for 2 to 3 years. You were assigned to that project, and then you were moved to another one. It's one of the changes that we're going to talk about in the industry is the big mega projects have gone down to smaller projects, and the teams, the engineers, the way they work are no longer on these huge teams. It's more of a structured small team. And that's just kind of the way the industry has gone. I mean, I started off designing large coal. Those plants are being shut down for good reason. Then I worked 7 years in the nuclear power industry and worked on that. Then I started working in combined cycle gas turbine plants. My last career, I've been lucky enough to be working on renewable energy, doing geothermal energy design. We do projects all over the world. We have projects currently in Turkey. We have just started a project in Kenya. We've done work in Mexico. We've done work in Venezuela. We've done work in Nicaragua. We work all over the world. And we actually design those plants here in Idaho, which is very cool. So it's just the way the market with the geothermal industry, and Josh will talk more about it because he's one of the young experts. I'm kind of the old dog that came along and wanted to learn one more new trick before I retired. But I was able to, at the end of my career, I was able to be the project engineer for a solar thermal installation. It was a solar thermal augmentation of a coal-fired power plant where they actually put a solar thermal system and augmented the existing power plant. In that case, we actually took feed water from the coal plant, directed it out into the solar thermal field, produced superheated steam, brought it back into the coal-fired power plant, and ran through the existing coal-fired boiler. So what we were doing was reducing the emissions when the sun was shining. So we did that project down in Tempe, Arizona. Very cool project. I also got the fun time of putting together the first solar thermal augmentation of a geothermal power plant in North America. So what we had was a binary geothermal power plant over in Nevada called Stillwater. It was a 50 megawatt or about a 40 megawatt binary power plant. When you say binary, it's low temperature, about 300 degrees, water coming out Well, they had a number of wells, about 6 different wells, and 2 of the wells actually, the flow was going down and the temperature going down. So when the flow goes down, your throughput for your turbine goes down, so you're producing less power. So the options are drill another set of wells, or in this case, we actually put in parabolic mirrors and ran the geothermal brine out of the ground through the mirrors into the expander, the turbo expander, brought the plant back up to its original output. So the first time it was been done in North America. Economically, probably still doesn't pay well, but the company we worked for was an Italian company, and now they wanted to wear the green crown, and we were lucky enough to be able to do the design. So very interesting stuff. But lately I've been involved in battery storage. That's a big thing in the California market. As you're all aware, California is going from, they have an assembly bill to go to 50% renewable by 2030. Well, as you introduce additional renewables on the grid, you have to be able to back up the grid and still maintain the voltage and frequency. So in localized areas, they're putting in battery storage. And we just finished a project down in Pomona, California. It was an 80 megawatt hour facility. And at the time, it was the largest facility that was done in the United States. Tesla came along a week later and put a bigger one in. We celebrated for a week. We actually moved our ceremony up so it would be before theirs. But anyway, so one thing I can say is, I've gone from coming out of college, working on these very large projects, back then with pulverized coal, to doing state-of-the-art geothermal and solar thermal, and now battery storage. I keep telling all my colleagues that I'm bottom feeding. I said, I know thermodynamics, but anyways, sometimes, you have to just realize you've got to be able to augment the grid and be able to put in that a number of renewables and still maintain the voltage and frequency on the grid. So that can be a challenge. But one of the things that I'll talk about is just how engineering's changed since I started. I mean, I hate to date myself, but we didn't even have personal computers when I graduated. I had a calculator. I had an HP 45. I was telling these guys on the way over that I spent like $500 on it. And so we never learned slide rules. Our professors all had them. And then when they gave us the examinations, if you didn't round to significant figures, you were out of there. Because these guys, they were not happy that you didn't have to sit there and, do the slide rule with them. But everything was, was structured that way. And then when I first got out of school, we were designing large, Rankine cycle reheat power plants, very complicated power plants. And, same cycles that they're done today, but we used to have to rent time on the mainframe. There was companies out there like Boeing Computer Services, and you would rent time on the mainframe, and you'd spend a couple days getting all your data ready, and then you'd run into the terminal and you'd key in all your data, and it was done on a batch file basis, and it came back, like the next day your stuff came back, and you're like, oh, that's amazing. But, I still have a deck of cards at home, because we were, like for heat transfer, I remember doing a two-dimensional heat transfer program we did it on a matrix, and you had to punch all the cards, and I had a stack about that thick, and you always had a backup stack in case you dropped or lost yours or something. It was, you turn it in, and then they'd run it, and then you'd get a stack of paper back, and you would always hope to get a big thick stack. And instead you got one page that said syntax error. And then you'd have to, then you turn it back in, and then you got another single page. Like, oh, no. And then finally you got a matrix printing out. You're like, yeah, okay. anyway, so it was all interesting. Yeah, it's a little easier now, so yeah. I'll let Josh talk a little about what he's doing, because he gets to do a lot of the good stuff. My career is kind of, you start off doing the engineering, and there's really kind of two career paths within a company. And usually you either stay totally in the engineering, or you can actually get into the project management side. Power, I mean, it's pretty good because you still are responsible for the overall success of your project. You're just responsible financially. But you have to have an understanding of what's going on, enough of the engineering side to ask questions. You've got a project engineer, and I still project engineer. I like to, on some projects I like to be the project engineer, and on they like me to be the project manager on the bigger projects. And so that's kind of a different career path. But usually the companies will actually ask you if you have any interest in that. There's guys that don't have any interest in that. All they want to do is the purely technical. And then there's the others that are involved in, you know, actually managing the projects, looking at earned value, you know, a lot of things that you look at from an accounting point of view. And then the other part of engineering is, to be a successful company, you always have to have work in the door. Wherever you get work in the door, you got to go out and look for it. And so there's a whole marketing aspect that you get involved with. Some people say the best way to get work is just do good work, and you keep getting it from the same client. That client can have some upturns and downturns, so you constantly got to go out and look around and try to find other work. So there's certain engineers that you know are good marketers. Josh, on one hand, or Tony, they're good. I mean, I can tell you others that aren't here that aren't. That you wouldn't want to take to the client to go get a job.
But they're probably still good engineers.
They're very good engineers. Yeah. Some of them need to stay at their desk and do engineering. But that's kind of the difference when you're working for an engineering company. One of the good things about Power is our company is still run by engineers. The CEO of our company is an engineer. So, you know, it's kind of like we all kind of talk the same language. But I'm sure he hasn't done any engineering in a while, but he still, you know, knows what they're doing. So there's other bigger companies where you're just the engineering arm of a large company that does, for example, construction and engineering. When I worked for Bechtel, I used to tell us that you're only here because you have to be. Engineering, there's too much risk for a company. You know, you don't make enough money. We make everything in construction. You're just here because you have to be. That was kind of what we were taught there, is where now you work for a company that's all they do is engineering. So it's a good thing. So I'll let Josh talk, and then we'll ask for any questions unless anybody has any for me. I have season tickets for Boise State basketball this year, so.
Yeah, you can catch them at the game.
My friends told me I couldn't wear any of my Gunderson stuff.
I'll just start by saying, like, I want to be informal and have a kind of a dialogue. So if at any point somebody has a question about something I've said, just interrupt them and raise your hand, or even, you know, calling for my attention, because I don't want to get too stuck on what I'm trying to say. And after I'm done, we'll transition into sort of a Q&A, so that anything that you want to kind of dig a little deeper on, or questions about something you haven't even heard about yet, feel free to ask, and one of us will try to answer your questions. So my name's Josh Gunderson. Like Steve said, I graduated from Boise State. I didn't grow up in Idaho, though, so I want to just kind of talk about my career trajectory, where I came from, how I got to where I am today, and then I want to go and talk about what I do right now, kind of day to day, the tools I use, the things that I learned in school, or the things I learned along the way, even like attitudes and practices that have been helpful to me in my job. Hopefully that'll be valuable. So, go back to high school. I was a pretty average student. Nothing too much to write home about. I left high school, and instead of going straight to university, I joined the Air Force. This was my dad's plan for what to do if I didn't turn in any college applications. So it was good that I joined the Air Force because I wasn't terribly self-motivated at the time, and even though this is my dad's big threat, you know, that you're going to have to join the military, pick a branch if you don't find your way into college, I kind of knew even before I ran out of time that that's what I wanted to do, because that lack of motivation I felt was going to cause me to waste whatever of my family's money, whatever of the government's, you know, funding for me or loans that I took out, because I was going to get to college and just, you know, wasting time. So I thought I should grow up a little bit. So joined the Air Force, and it was a really great experience. I feel like I went in, you know, just some kind of video game playing, apathetic, you know, 18-year-old, and I came out a person that had some aspirations, some goals in mind, things I wanted to accomplish, and sacrifices I was willing to make to achieve those sort of milestones that I had out front. So again, the military was great for me, even though I didn't get to see the world as much as I kind of thought I might. They told me when I was in basic training, you're going to the East Coast, you're going to, I think it was South Carolina. I thought, great, this is a change of scenery. It's not in Italy like I was hoping for. You know, you kind of write down where you want to go, and then they tell you where you're going to go. And so I thought, but that's okay. I'm far from my parents. I'm on a different ocean, right? Because I grew up in Washington by the water. So this is good. And about a week before I shipped out, they said, change of plans. You're going to Idaho, Mountain Home Air Force Base. I thought, never heard of that Air Force Base. They said, don't worry, you'll like it. There's a girl behind every tree. I didn't get the joke till I got there. I was like, oh, Mountain Home has no mountains and no trees. I get it. All right. And but I like a challenge, so I found my wife in Mountain Home, and it was good. I enjoyed my time there. It's a great little community. I didn't fall in love with Mountain Home, but I did fall in love with Boise while I was there, and my wife. And when I was proposing to her, I realized very clearly. I remember thinking this. Okay, I'm not just marrying this woman. I'm also marrying this area, right? Because she loves it here. She wants to live and work here. She wants to put down roots here. She's got family here, and she'd like me to be her family here too, and not just go, you know, wherever the work is. So we agreed at that time that if need be, I hadn't even picked a career path yet, but if need be, we would move away, but we would try to come back, right? So many of you might be in that kind of same boat, where you're thinking, I really want to stay and work here, but you know, this place isn't exactly flush with, you know, high-tech jobs, and so you might have to move away and try to come back. It's a tough situation. That's one that we all might face. So that was, I didn't know what I was going to do yet. So at the time, I just thought, we'll see, and hopefully I can find a career path that'll let me stay. We'll see. First year, I just dove into math and science classes. I thought, this is something I'm good at. I don't hate it, right? I like math, I like science well enough. Let's see if something sticks. By the end of my first year, I was thinking mechanical engineering. So it was kind of a pretty quick process for me making a decision. And then, because GI Bill money lasts for 4 years, I thought, okay, first year's done. I know what I want to do. Now I have to pack, you know, 3.5 years of classes into 3 years and get the heck out of here. So that was the plan. Executed it pretty well. I really enjoyed campus life, even though I didn't live on campus. I was one of so many people that commute to campus. Right? We're kind of a commuter campus still, I think. Not as much as it used to be. When I was here, that was kind of our thing. And so yeah, I didn't live on campus. I was married for part of the time, you know, driving out here and back. But I really enjoyed the time I spent on campus, and I spent a lot of time on campus. You can't really do mechanical engineering in 3.5 years and not be here a lot, right? So as you know, it's 12 to 14-hour days here on campus. You pretty much eat 3 meals here, right? Might go to the gym twice in the same day, you know, that kind of thing. But it was great. And degree in mechanical engineering, goal to find a job in Boise, right? So it's a pretty short list of companies and job opportunities compared to a city like Houston, right? Or you know, you go to Florida or you go to Chicago or Boston to find lots of job opportunities. Yes?
Did you have any internships or do any research that was related to energy before you got your degree?
Did not. Wish I had. I got lucky and found my job without that. But looking back, I was playing a dangerous game because I feel like networking is the key ingredient to getting a face-to-face interview, and having a face-to-face interview is kind of the key ingredient to getting a job instead of being just another piece of paper in a stack, or worse yet, just another of 500 online applications, right, that someone has to sift through. So you're just a number. Here's some metrics. Whereas if you can get in front of somebody, now you're a person that can be related to, that someone can walk away from the interview thinking, oh, I like that guy. or I like that girl. She can
Yeah,
be.
I would emphasize internships as a very positive thing. I did 2 of them. I did one actually my junior year and my 2 years before I graduated. We hire interns at Power. We hire a number of interns, and we have permanently employed many of them. That's just a really good way to get going. I highly recommend that.
Absolutely.
On the same topic, I guess, so my friends in like other, like not STEM majors, I see them graduate and then like try to apply for jobs where like, it's like, we need a bachelor's in this and like 5 years of experience. Is that common in, like, will we have trouble finding entry-level jobs and will getting lots of internships help us?
I think the internships help because at least you don't come in saying, I have no experience,
experience.
right? You have some experience that's greater than 0, even if it's less than the 5 they put down. I think a lot of times when companies ask for 5 years of experience, what they're really saying is, we'd rather not have to train you because that takes time and money. And so you're up against what they really want is they want a transfer, not a new hire, right? They want somebody who already knows the business a little bit so that they can just be effective right away. But I think all companies also realize that that's not, they don't always get their way in that regard, right? So to me, the way you fight that, I think you still apply for jobs that require experience. I think you still do. It doesn't cost you much, right? But I think you have to tune your application, your resume, and your whole approach to trying to point out where you can counteract for the lack of experience. For example, if you have some way to demonstrate how quickly you can come up to speed, like if that's something you can show that you're good at, then that's something to really try to market for that application. I haven't applied to a million companies, so I don't have a ton of quantitative experience here. I've been very fortunate, but that would be my approach. So on that topic, I applied to 3 or 4 places in town, and to me it was like, okay, I'm going to apply to 3 or 4 places I really want to work at, see what happens. The next cast is going to be not 3 fishing poles, but a net, right? Like, okay, I'll take whatever I can find, and then the next cast is probably going to have to go outside of the area, right? And I got lucky because on the first cast, Power Engineers was, I think, number 1 on my list, and I got that job. But I got that job, I would say, because I got an interview. And I got an interview at a time when the company wasn't hiring for my position, or in my department, or anywhere in my, they were looking for high-level management types like Steve. They weren't looking for anybody like me, because they were already flush with people like me. So I happened to know someone who got me a face-to-face where I sold my ability to come up to speed fast and be productive. And it worked, right? But it won't always work. So I'm very fortunate. I think if I'd had internships, I would have stood a much better statistical chance of succeeding. But I feel like I kind of luckily hit the bullseye, right? So came out of Power 2008, tough time to hire engineers. And now I'll kind of transition to what I do every day. So I focus mostly on thermodynamics in power plants. So heat exchangers, pumps, turbines, gas turbines, and heat rejection equipment, cooling towers, air-cooled condensers, thin fan coolers, all these types of thermal equipment within the power plant. Sizing them, how to arrange them, and then also just in the early stages of project design, what sort of power plant should we build for the resource? Because in renewable power, you have a lot of options, like with geothermal. There's a lot of different types of plants you can build to extract heat from hot fluid, right? Whereas in more conventional power, where Steve comes from in his past, right? You're burning coal or you're burning gas, and there's some variations on what you can do there, but for the most part, it's the plant design is pretty straightforward. You're just trying to get a little more efficient or a little cheaper than the last time you did it, right? But you're not really redesigning the thing or trying anything too new.
I laugh compared to geothermal when they talk about high pressure steam and high temperature brine. Well, like in the conventional power plants, we invent that stuff.
Yeah.
Not even worth it.
Yeah, geothermal, you talk about high pressure steam, and it's like a tenth of the pressure that they deal with routinely in fossil power plants. So, 20, very small.
Yeah, I mean, a conventional power plant, you're looking at like 2,500 psi to 1,000 degrees Fahrenheit. Right. Now we're designing the geothermal plants at less than 200 psi.
Well, yeah. 100 pounds is not uncommon for the the supply steam to a geothermal power plant. So when you hear about a 50 megawatt geothermal power plant, that's pretty small compared to a 1,000 megawatt combined cycle. But 50 megawatt geothermal power plant will have a pretty massive steam turbine because that steam has not a lot of energy. It's pretty interesting. And the number of components that go into the plant are comparable to a combined cycle power plant. And so the amount of engineering that's required will be similar just on that count alone, but the fact that every geothermal power plant is different means that everything has to be tuned and adjusted to that particular geothermal resource. And so it actually takes, in some cases, I would say more custom engineering to design a 50 megawatt geothermal power plant than, say, a 500 or 600 megawatt.
Because when the energy is literally free coming out of the ground, you will spend a lot of engineering time to extract the last bit of efficiency that you can because you can operate it,
Right.
Whereas in the conventional plant, it's like if you look at the cost of the gas, it's like, who cares?
And with geothermal power, by the time the engineers are working on the details of how to extract that power most efficiently, the developers have already sunk a ton of money into drilling, right? And they want that money back. So there's already this huge investment, whereas when you're doing the design for a fossil power plant, the only thing that's in place so far is like permitting and fuel contracts and things like that. It's not as much money already sunk.
So you mentioned earlier that you guys are working on a number of projects around the world. How do you guys overcome the challenge of not being at the site and dealing with that directly, but yet you're designing it here?
Multiple answers to that. So on the one hand, the design work itself, you don't have to be on site too much. You'll get good like topographical, physical information about the site, right? You get like geospatial information that you can use to design with.
Our design work is done in 3D modeling. So you sit in front of the computer, you're at the plant that you're designing. So everything is real scaled to 3D. When the plants are built, then we send people to the field to answer questions of the construction. When the equipment is started up, then we have people that go to the field that are there when they start up and commission the equipment. But if you look at the duration, the design is longer, the construction, is a shorter period, it's intense, and then we send people out there for startup. So, I mean, if rather than the Navy, if you want to see the world, you come design geothermal power plants in town.
Yeah, we built what we could in the U.S. There's not a lot of new plants going in the U.S. for that reason. It's not because we don't want to. It's because it's a limited resource. In terms of location, right? Geothermal power lasts a long time in terms of your ability to keep drawing from it. But once you're there drawing from it, you have to go find some other place to go drill wells, right? And after you've drilled wells in all of the prime locations, you go someplace else, right? And currently there's a lot of activity in Africa. There's a lot of activity in South America, Central America. There's activity in Mexico.
Yeah, one of the things that you're seeing is in the world economy, renewable energy is really bringing power to people that couldn't have it before because, the cost of the solar is the cost of just getting the fuel, for example. We're working on a project right now in Sierra Leone, and they don't have a reliable grid. They have a grid that's got power on it most of the time during the day. At night, they don't have it. We're looking at putting in basically a photovoltaic plant along with a diesel generator backup. And the issue is, the cost of getting the refined fuel there to burn was so expensive that now you can come put the solar panels in there and at least you can get power during the day. So it's really changed the world economy as far as how you can get power to people. But the idea is eventually you'll be able to put in enough solar and enough batteries that you won't be looking at too much.
To build on your question about how do we manage this at long distance, like Steve said, when you have to be there in person to answer questions and help things come together, a company like Power, we're a consulting engineering firm, so we don't build the plants, right? We design them, and so we're not sending 100 people to the site to build it. We're sending 2 guys at a time to the site to be there and answer questions, engineering related to our design and drawings and plans, and solve problems as they pop up.
Yeah, that's usually done on a discipline level.
Yeah.
When they start digging the dirt and putting the cement in, you send the civil and structural engineers. You start putting the equipment in, you run the piping, you start sending the mechanical engineers. When they start wiring and hooking up the control systems, the electrical control system guys.
we've had limited success. We've had limited success with the idea of like telepresence, I guess, if you will, Skype or something like that. It's not perfect, right? There's lots of technical issues that seem to happen to us when we're trying to do that. You can still run into language barrier problems, but it does work, right? And time zone problems, right?
Time zone is probably the biggest thing.
Yeah.
We do work, when you're doing work in Asia, you're going to work late, you're staying until 10 o'clock every night because your calls with Japan start at 6 o'clock. As opposed if you're working with the Europeans, you come in at 5 in the morning because you got to catch them before they go home. What you really don't ever want to do, and I've been there, is you don't ever want to have one client in Europe and one client in Japan. Don't ever do that.
Yeah.
Then you don't. they want
Someone's
to-
not sleeping.
Just put your bed in your office.
Yeah. Right.
Yeah.
There's also some work going on in augmented reality too, where they can take, the 3D model on like an iPad and hold it over the place where maybe a pump is being installed. And you can help get an idea of how the real world reality matches with your virtual model.
So rather than having an engineer having to go from a work camp office PC where they're looking at a 3D model that we built for them on site, they're looking at that and they run outside, but that run outside is like that's 5 minutes walk away, 10 minutes walk away, come back. They can actually take the model and overlay it on what they're seeing. Compare our design to the as-built. That's pretty new though. Yes?
So my question is about that feedback loop on your designs. If you made a mistake on a pump on a power plant, it's not going to fail for 2 years. When that happens, from your standpoint, does that come back to power? Is that somebody else's problem? You don't even hear about it. How do you get that? What's the duration after they buy off the plant?
So, Steve, you may want to build on this a little bit beyond
But
what.
unfortunately, I know way more about that than I should.
That's a project manager question. Risk
management.
Yeah.
As an engineering company, you have to protect yourself. So you buy professional errors and omissions insurance policies. You can't be a business, especially a public company, where you're performing design work that could have consequential damages of millions of dollars. And so you have to insure yourself for that. In the case of, you're talking about a pump failing for 2 years later.
I'm just thinking of, as a designer, it's an iterative process. You want, even aside of liability, you want information on your failures, right? So that you can, otherwise, how do you make good designs, right? So I was just wondering knowing that you're not building a plant, you're not operating a plant, what does that feedback look like?
Not as good as it could be. The owners in many cases are not really incentivized to send information back our way. Because like Steve said, the way everything's structured is usually we will not carry the risk for something that breaks the field, unless it can be traced back to a decision we made, and that decision can be shown to be not only wrong but negligent, right?
Yeah, in our contracts, there's the design work, and then there's typically a warranty period. And the warranty periods can be up to 5 years. So you can be exposed to that.
But typically the risk tends to fall back on the equipment suppliers, who also review the plans, and so risk is going to tend to fall on people who stand to profit the most, the people who tend to have the most expertise, the people who have the most control for a particular area. So it depends on why the pump failed, but if there's some manufacturing defect in the pump, they're not usually going to come back to the consulting engineering firm who said, yep, that's the pump we ordered. It's usually going to come back on, if we've written a tight specification, it's going to come back on the supplier of the pump who didn't meet that specification.
Power plant engineering is I don't take this wrongly, but it's not exactly R&D cutting edge. We're using proven equipment and we're packaging it together to optimize a system. Rarely do we get involved in R&D type work. I mean, R&D work is out there, it exists, and people pretty much know that when you're doing it, that nobody's ever done this before. Nobody's going to sign up for a 5-year warranty you're gonna make your best sound engineering judgment of it, it may or may not work. I mean, the government loves to sponsor things through the Department of Energy, like their whole, clean coal program or something, where they're doing R&D technology. Usually that technology, if it works, can be taken into the mainstream industry and then people use it. So we tend to be fairly conservative.
In that case, would there be like any backup cycles or pumps and systems like that, or is that dependent on the client?
Part of designing a power plant is to identify potential failure points, and where you have a particular prime mover like a pump, say you have a cycle pump that's moving cooling water. Cooling water stops flowing, plant stops working, right? Let's say that you can buy a pump to do all of the moving of the water that is needed for this power plant to reject heat, right? That may be the most cost-effective thing to do, buy one big pump. Problem is, one big pump can have a problem, right? So you have two options. You can buy 2 or 3 smaller pumps that add up to the same capacity, and you can figure, if I lose one, and I probably have the same, well, yeah, now you have an increased probability because now you have 3 failure points. But if you lose any one, you still have 2/3 of your flow. And if that's tolerable under your power contract or whatever other process you're serving with this equipment, then that's maybe the way you move forward. But if it's not tolerable, the penalties for not being online are really stiff. Then what you end up doing is saying, all right, well, we're going to need redundancy. So I have to buy 2 pumps that can do all the work, or 4 pumps each can do 1/3 of the work, so that if any one goes down, I have a spare, right? And that's, you end up comparing these different alternatives to see which one makes the most economic sense.
Now, oftentimes our clients nowadays, see, when I started in power, electric power was generated by the utilities. Utilities built their own power plants, they designed their own power plants, and they operated them. Well, deregulation came along, and suddenly, utilities are no longer responsible for, or not in the business of generating the power. They're basically distributing the power. The power, like in California, is actually being bid into a competitive market. So there's these power contracts that'll have reliability, and then often our clients will come to us and say, you design us a power plant, talk to us about how we can meet this level of, we call it capacity factor, which is basically just how much downtime are you going to have between failures. You can actually do a very statistical analysis. You can look at mean time between failures. And, it can get pretty complicated, but normally in power industry, they tend to be fairly conservative. It also allows you to do routine maintenance while you're online. You don't want to shut down every time you have to do any kind of maintenance.
So what would a typical day kind of look like for a mechanical engineering intern that you guys might hire?
So, intern. I would say that typically an intern is going to do things like hydraulic calculations, right? Because that's not too much of an extension from what you're used to here in the classroom. You may end up doing some things that feel a little menial, like lists, and it's not administrative work, but it's engineering administrative work, helping to keep things organized, keeping track of data. You may begin to work on process and instrumentation diagrams, but you wouldn't be the sole person working on those.
Maybe doing some drawings, schematic drawings.
Yeah, right.
And that's a good way to get the hang of it, see how the systems go in typical assembly.
Yeah.
You might get a little CAD work, might get some rudimentary calculations that have all, like there's a kind of a template for you to follow, right? Kind of just repeat them. And where the goal is more your accuracy than your ingenuity. So that's where it can get a little boring at times.
Yeah, before I came to power, I worked for an operating company in California. So I spent 30 years in California and then came up here about 7 years ago. And in California, we basically know that you cannot bring in experienced engineering talent and have them move to California from Omaha, Nebraska. I'm sorry. Go look at the housing cost prices. You just can't do it. So we would have to hire people and train them. That's the only way we could really bring in engineering talent, because we couldn't hire experienced power engineers, because there's certain areas in the country like Kansas City or Houston where that talent exists. Well, come on to San Francisco and let's try to buy a house. Yeah, that doesn't work. So we would have to hire young guys, and I used to bring them in, and I was looking to hire them. I was just strictly bringing in interns, looking to find the smartest ones I couldn't hire. I used to give them work. I used to give them the most complicated work I could to figure out how much they could do before they threw their hands in the air. So,
The other thing that comes into play a lot, and it's kind of an industry changing sort of a topic, is preparing your work for sharing with a client or for submission. So turning your calculations into a report, for example. If you go back to the 60s or something like that, you would do your calculation and then you'd hand the information over to somebody else who would make a report for you. You had technical writers, you had typists, you had all these different roles, right? And nowadays, with the advent of personal computing and word processing software that everyone's kind of expected to know how to use, every engineer has to be kind of a full package. You have to be a technical writer. You have to be able to put together a good email, even as mundane as that sounds. That people do it well, people don't do it well, right? And so, typical day, as you move from an intern into a full-fledged engineer, you're going to be doing a lot of office communication, and then outward communication to clients and equipment suppliers. So I think the tool I use the most in a day is Outlook, followed closely by Excel, after which all the various engineering software packages that we use. It's funny though how you wouldn't think Excel would get as widely used as it does, but it's pretty massive. I don't think there's any one tool in my toolbox that I get more out of than Excel, actually.
Don't forget Google and Wikipedia.
It's helpful
for an intern, that won't understand it.
Right. Sometimes when someone gives you something to do and you're actually not entirely sure how to do it, you have two choices. Figure it out on your own or go back and ask for help. And I always recommend trying first to figure it out on your own. And Google is your best friend at that point. Yeah.
Be a little careful. There's a lot of companies that hire interns that don't have the people to spend time with them to make sure they're like, that happens typically at the, I don't want to pigeonhole them, say the bigger companies where they just have a budget to hire interns. And it's like, but they don't, the people doing the production work don't even have the time to have people help them. They're just too busy. So,
it's like throwing 20 rats in a box and feeding enough for 5 and seeing who's left in a week or month. It's kind of, the big shops, it's like that. So you gotta, only the strong survive, right? Everyone else can try again someplace else. We don't do that at Power, I would say.
No, we're pretty good about it.
We bring on new hires in pretty small doses, and we're pretty stable with one, so not much attrition. Yes?
Yeah, you were saying that typical communication is a good idea, so what about having an actual number?
Not a bad idea at all. Two things that maybe three things that are good. The question was, we mentioned earlier that technical communication is valuable, and would it be beneficial to have a minor in technical communication? I would say there's a handful of minors that would be beneficial, and whether or not you have a minor, just taking coursework and developing your skills in these areas. Technical writing, programming, computer programming, and there's another one I thought of, business, right? If you want to take that project manager track and get more into management, graduate kind of out of pure engineering and into engineering management, it's good to have that business background. If you're going to be more of the technical track, right, you're going to not only be solving problems within your company, developing solutions to problems, but you're also going to be developing standard solutions within your company, because now you're the subject matter expert. So you'll be expected not only to have an opinion, but you'll be able to articulate it in a way that becomes standard operating procedure within your company. So technical writing will be huge for people who want to take that more technical route.
I remember when I was in school, it was kind of like two buckets. There was like the technical bucket and the business side, and we all graduated and thought it was the evil. And I realized throughout my career that if there isn't a return on the investment that you're working on, you won't have anything to work on.
I still have my head in the sand. I'm a technical guy.
Get over it. Get over it, unless you're working for a pure research company that gets budget from, say, the government or part of your organization that can fund R&D. If you're in a business for profit like we are, you pretty much have to merge. What's the three things they say at Power? The three statements. Yeah,
have fun,
make money. That's the company tagline. The three things.
Do you guys all have programming skills, and what, if so, like what languages do you utilize the most?
Some of us don't.
I would say.
When I learned Fortran.
Well, you actually had to do some programming.
Yes, I did.
In your career after college. A lot of us don't. Tony, I don't think you have had to really.
I did a little Visual Basic, but I could have, and Josh could have easy enough.
Speaking for my company and mechanical engineering, I would say maybe 1 in 10 of us really does any substantial amount of programming. But I will also say that we probably wish we had more people that had that as a strength. And I have felt in my career path, everywhere I've worked, a little bit set apart, like I have an advantage because that's part of my career. And I'm not great at programming, but it's something I'm comfortable with. I can get up to speed in whatever language you want to throw at me. Give me a little time. That's how programming is, right? Once you kind of get a few languages under your belt, you can kind of move around. And I think having that skill set really is an asset.
Do you see that changing in the future?
I think
or increasing in the future?
I think so, yeah. It's tricky because there's two things that happen in the industry, right? One is automation increasing and the use of computers increasing. So that's going to increase the need for programming. The other is consolidation of expert skills, right? Which tends to happen where we used to have people who could like do a certain task, but now we have a machine or a company that does it, and now nobody knows how to do it anymore, right? And so I think there's this idea that we are going to need programmers more and more and more until there are so many tools out there that you don't actually need to program anymore. There's always something that does it. Like artificial intelligence will eventually solve our smaller problems, and I won't be able to write code to solve that problem. I'll just have to ask a computer to do it, and it will write the code to do it for me, right? So,
Build PowerPoint.
Short term, 50 years. Yeah, right. Exactly. Well, on that note, so you said you had to run all these calculations to design a PowerPoint, and you had to walk down the street, submit it to the mainframe, and all these things. It took all this time, and if you got it wrong, you started over. It was this laborious process, and now they have off-the-shelf, and have had for 10, 15 years, off-the-shelf computer programs where you go, all right, that's my fuel source, pick it from a drop-down. Here's my ambient weather. Oh, I don't know what the ambient weather is. Well, that's the nearest city, that one, okay? And move on through, here's 10 different typical plant arrangements, depending on what kind of water you have available for cooling. Okay, that one seems good. Run, all right? So that it goes through and it economically sizes all of the components in the power plant, right? Right down to doing all of the thermodynamic calculations for the heat exchanger, 1 pass, 2 pass, all that detail, how many exchangers are there, turbine, boiler, steam turbine, heat rejection, cooling towers, all these things are being designed, sized, their performance assessed, drawings, simple drawings created, their costs built up, right down to how much it's going to cost to deliver it to the site that you picked, right? And if you put the right information in, it'll also crank out a 20-year economic pro forma. And the whole thing takes about 12 seconds. So once you press go, it took 2 minutes to actually fill out the form before you pressed go. Now, that's awesome and horrible at the same time, right? Because on the one hand, how much less time is that, right? And you can try lots of different options. On the other hand, it's very easy to lose sight of what's going on, right? So that if you ever need to actually go back and question any of those assumptions that went into this black box that spit out an answer, you will have lost it. So, yeah.
So there are other disciplines to add on to that use quite a bit of coding. Controls, and electrical,
They do
those guys
all of
code
it.
all the time.
Yeah.
So,
Yeah, I was speaking for us
Yeah.
piping and equipment.
so it's not a bad idea to get into that, especially if that's your passion. To look beyond just mechanical things, and a mechanical background certainly puts you in a good position to have a technical base to go into those other areas of design.
I'll add one more thing real quick. So on the programming note, we're all going to use software tools as engineers, or as in any technical profession. You're going to use software tools. I can't think of a software program that isn't made better if you have a programming background. They all have some kind of automation capability that you can't take advantage of if you can't program. So you become a super user just by having that programming background. So that's a good argument, no matter where your career path is headed. Yeah.
So I have a question. I strategically waited until you have 2 minutes left. So from your perspective as engineers and as people who see new engineers coming out, what are engineering schools doing wrong? In 2 minutes.
I think there could be more hands-on.
Yeah.
Getting dirty. You got to get out there to the construction sites, dodging bulldozers. Learn how to work safe.
One would argue more real-world experience, less theory.
I have an add-on to that because I agree, and I happen to run senior design, so this is my job. And I have a project right now with Power Engineers, and it's the only project I have that has none of that in it. Right? You're a consulting firm, right? So like, how do we do that?
It's hard with consulting firms.
So
I wish I had more hands on me. Right?
Now there's only 30 seconds left.
I think a quick answer to that is some engineering jobs are abstract, right? And so by having some projects where you build things and some projects where you only specify, procure, or analyze things, you're giving people the full spread of what you could actually do. Not everybody gets to design moving parts, right? Some people have to study the economics of those moving parts, or look at, as we do, system design, right?
I'm just expand on that one. That's kind of what I was thinking.
Consulting engineer, like we don't decide how to build a pump, ever. In the old days, like 40 years ago, we might have got into the weeds with a heat exchanger supplier and argued about how to do it. These days, that's gone, right? They do it. We tell them some basic parameters, what I need to do. But the actual decision of how it's constructed is mostly by the equipment supplier. They're the subject matter experts. And so that division of labor has become, I would think, less of an overlap on that Venn diagram. We do more system design and specification and procurement, and they do the equipment design and try to meet our performance targets and drive down the price. And that can be unsettling if you work in a firm like ours, but you want to build stuff, right? And I think that's another thing that we can do to serve students well, is to make sure they understand the full spectrum of what you can do as an engineer. We're not all going to get out there and build rockets, right? Some of us are going to have to do some pretty boring stuff, which may still be enjoyable for us depending on personality. But you have to know that about yourself. You have to know that about the industry, the kind of work that actually has to be carried out. I used to tell, when I was doing adjunct teaching here, I would always take it as my job to be sort of the Debbie Downer and say, look, guys, we don't all get to go to work every day. Once you're out there and solve problems. And what I mean by solving problems is solving our energy problems as a society, or solving social disparity problems, or whatever you want to go for. That you don't all get to go do that. Some of your job is kind of like to save someone money, right? That's the nuts and bolts of it, and that can still be challenging and can still be enjoyable as long as you go into it with your eyes wide open. Because you don't build the strongest bridge you can. You build the cheapest bridge you can. That's how corporate America works. That's how the world works, right? And that can be really fun and challenging, but very few of us get to go out and build the best thing we can build. Most of us have to build the least expensive, with the least material, with the least labor.
The most okay.
Which it's not bad. It's just different, and I think it's good for people to realize that, because I remember coming out of school and being kind of disillusioned. Like, what do you mean I can't find a better way? There's no time. Nobody wants me to. Nobody wants me to find a better way. All right. But there's a little bit of that. I don't know. Does that make sense?
Sorry, you guys are probably out of time, but so would you say like Power doesn't do a lot of R&D, and is that like going to change in the future, or?
When you say R&D, I mean, we designed the first triple flash plant in Turkey, the first triple flash geothermal plant in the world. We did that. Are we running around testing aluminum to get some statistical failure that they're using in airplanes? No, we're not. So in our industry, we're doing cutting edge stuff, but whether you want to call that R&D or not, it's a matter of
the processes. We design the processes.
Yeah.
Someone else is designing the equipment to make that happen.
Maybe that's it. If we have maybe one last question, but I know we're probably kind of at the end of the time here.
If you have time, we can stick around.
You gonna be able to hang out? Okay, yeah, so let's go ahead and
Go back to work.
sort of like the informal sort of discussion time here. We can stop that here, give them a round of applause, and then we'll